Now let's see how to perform ANOVA using the R programming language. In this example, we have the tomato sizes for three different farms A, B, and C. Tanaka-san wants to test if the tomato size, the means of the tomato size of at least one farm is different from the rest. So this is the data. Let's start doing the computations. First step is to compute the sample mean. This is for farm 1, sample mean and standard deviation. Farm 2, farm 3. Then we have the grand mean over here. Once you have all this, you need to compute the sum of squares between and then the mean squares between. So this is the mean squares between. Likewise, sum of squares within you can compute using the formula. Likewise, mean square within you can compute. We have 4 here in the formula, which is nothing but the number of items in the respective group multiplied by the square of the standard deviation, which is nothing but the variance of that group. We add them all up to compute the sum of squares within. Likewise, to compute sum of squares between, we subtract the respective group mean from the grand mean itself. We do that for all the three groups, square it up, and multiply it by the number of items in that respective group. That becomes the sum of squares between. So we have computed all of this, and now we are in a position to compute the F statistic. So this is the F value. To compute the P value, use the PF function and pass the degrees of freedom for between groups and within groups. And this is the P value. To perform ANOVA without doing all these computations, you can directly do it using the AOV function. Pass in the formula. We have the data in a data frame. The DF contains the size of the fruit samples from the respective farm and the farm itself. So size as a function of farm, pass it to AOV function and get the summary of that. This returns the F statistic we just computed, the P value, and this 6 metrics over here from DF to mean square within and mean square between. This is nothing but the ANOVA table that we just computed. Since the p-value is much less than the alpha level of 0.05, we can safely reject the null hypothesis and conclude that at least one group or at least one farm's fruit sizes is quite different from the rest. That is, the mean of one of the farm's fruit sizes is quite different from the rest of the farms. And that's how you can perform ANOVA using the R programming language.